Hello everybody. Welcome back to Calculus 1 online at FCC. In this lecture, we will discuss the quotient rule, one of the fundamental rules for differentiation. And if you continue your study of calculus with calculus 2, 3, and differential equation, you will see that this rule is used frequently. So let's take a look at what the rule is telling us to do. We have two functions, f and g. There are differential functions such that the function in the denominator is not equal to 0. Then, to compute the derivative of the quotient, we do the following. It is f prime times g minus f times g prime. That's the expression in the numerator of the fraction. And then divide this by g squared. Okay, so I'd like to emphasize what we should not be doing, and that is if we were to compute the derivative of a quotient, it is not simply f prime over g prime. Okay, and we had a similar statement for the product rule. Okay, now let's go ahead and take a look at a couple of examples where we practice this rule. The first problem says compute the derivative of h of x, where it is a rational function 5x squared over 4x plus 3. Okay, so to compute h prime, I'm going to apply my formula first. That would be 5x squared prime times 4x plus 3 minus 5x squared times 4x plus 3 prime. And then divide this expression by 4x plus 3 squared. Okay, so let me emphasize the important parts of this formula. I want to make sure everything matches. That looks good. Now I'm going to proceed with computing derivatives. Okay, so what do we get? The derivative of 5x squared is 10x, and this is times 4x plus 3 minus 5x squared, and the derivative of this linear function 4x plus 3 is 4. All right, the denominator is the same, and you can keep that expression as is. You do not need to multiply it through. If you do multiply it through, it is not incorrect. You can still do that. Okay, so now I'm going to multiply everything through in the numerator. This becomes 40x squared plus 30x minus 20x squared. Okay, the denominator is unchanged. I'm going to keep it as factored like this. And now the last step is to combine like terms. So the final answer should be 20x squared plus 30x over 4x plus 3 quantity squared. Okay, you can stop right here. There is no need to multiply this through the expression in the denominator. If you would like to do it, that's completely fine. Sometimes I see students making factorization in the numerator. That's okay too. So let's say you want to factor out a common multiple. So in this case, it would be 10x. So what do we get here? If we do this factorization, this becomes 2x plus 3. Okay, and on the bottom we get 4x plus 3 quantity squared. Okay, both of these are correct. Okay, you can leave it in this form right here that I'm boxing up, or you can also factor 10x out. Okay, either way, this is what the derivative of our function is. So notice what I've done as my first step is first identifying what f and what g is. So this would be my f, and 4x plus 3, that's g, and then setting up my fraction to follow this formula, and then computing the derivatives, carefully multiplying everything through combining like terms. Okay, let's take a look at the next example. Here we have another rational function, 3x plus 1 over 4x minus 3. Let's compute its derivative. So first, I'm going to apply the rule. So this is 3x plus 1 prime times 4x minus 3 minus 3x plus 1 times 4x minus 3 prime. We're going to divide this by 4x minus 3 squared. Okay, let's check all the important components. Here are the primes. Here is the negative sign right here, and then squared. All right, so now we can compute the derivatives. So this becomes 3 times 4x minus 3 minus 3x plus 1 times 4. And the denominator, I'm going to keep it as is. Okay. Let's multiply everything through in the numerator. So this becomes 12x minus 9. And here we get minus 12x minus 4. The denominator doesn't change, so that's 4x minus 3 squared. And notice that we have some cancellation here, so 12x and negative 12x, that's gone. So the final answer will be negative 13 over 4x minus 3 quantity squared. Okay, so that is going to be our derivative of h. And again, if you would like to multiply that through 4x minus 3 squared, you can, or you can just leave it as is. That is completely fine. Okay, one more example. Here is another rational function, x plus 9 in the numerator, and then x squared minus 7x plus 1 in the denominator. So let's compute the derivative here. We recognize that our function is a ratio of two polynomials. So let's set this up. This becomes x plus 9 prime times x squared minus 7x plus 1, okay, minus x plus 9 times the derivative of this quadratic. Okay, and then denominator, we are just going to square. Okay, let's highlight the important parts of our formula so everything is correct. Now we compute derivatives. So the derivative of x plus 9, that's just 1 times x squared minus 7x plus 1. And what do we get here? The derivative of our quadratic function will be 2x minus 7. Okay. And the denominator is still the same. Okay. Now, I'm going to pause here for a moment. I would like for you to FOIL these expressions, okay, and then carefully combine like terms. And then once you do this, okay, simplify it, we should get the following. Okay, so in the numerator, the expression should be negative x squared minus 18x plus 64. Okay, and the denominator stays as is. Okay, and that is the derivative. So what I would like for you to do is complete this step right here. Just for your own benefit, to make sure that you can carefully multiply through, distribute that negative combine like terms. Okay, so that is it for the fundamental formula. Okay, so this is what we will be using throughout this class. And once again, if you continue your study of mathematics, you will see that this becomes very frequent. All right, so now let's take a look at a standard problem in calculus where we're given a function and we would like to compute the equation of the tangent line to the graph of this function at a given point. And now we can do this with functions that are rational functions. So we have h of x equals to 2x over x minus 1. And we would like to determine the equation of the tangent line to this graph at x equals to -1. Okay, so let's go ahead and do that. We know what the steps are. First, we need to compute the derivative of our function. Okay, so it is a rational function. So let's go ahead and set this up to x prime times x minus 1 minus 2x times x minus 1 prime, and divide this by x minus 1 squared. Okay, I'm going to highlight all the important components of my formula, and now we're going to compute this. So this becomes 2 times x minus 1 minus 2x, and the derivative here is 1. Okay, x minus 1 squared in the denominator, that stays as is. And notice what's going to happen in the numerator. 2x minus 2x, that's gone. So we're just going to get -2 in the numerator. Denominator is x minus 1 squared. Okay, so that is our derivative. It's derivative function. The next step is to compute the slope of the tangent line at that point. So what is that? This is h prime evaluated at x equals to -1. So we plug in -1 for x in the derivative function, right? So that would be -2 over -1 minus 1 quantity squared. Okay, so what do we get here? This is -2 divided by 4. So the slope of our tangent line is -1/2. Okay, and the last step is to apply the equation of a line that goes through a point and a slope, right? So y minus y null equals to m of tangent times x minus x null. Okay, so do we have our point? Well, we can find the y coordinate. We have the x coordinate, which is -1. So if I evaluate h at -1, okay, our function, not the derivative, right? So that would be 2 times -1 over, what do we get here? -1 minus 1. So this becomes -2 over -2, and that's equal to 1. So our point has coordinates -1, +1. Okay, and now we can complete our task of finding the equation. So y minus 1 equals to -1/2. That's my tangent. That's the slope of the tangent, right? Times x minus -1. Okay, so that becomes positive. And once you simplify this equation, we should get y equals to -1/2 x plus 1/2. All right, and you can always check your work by using Desmos. So what would you do, okay, for this particular example? Okay, so graph this function. Okay, graph h of x equals to 2x over x plus 1, x minus 1, right? So graph it using Desmos. And also graph the point with coordinates -1, 1. It should be on the graph. And then graph this equation right here, this line, and see if it is tangent to the graph at that point A, right? So that's one way to check your work with a graph, and I encourage you to do it. Okay, so that's our example where we find the equation of the tangent line. We have done this problem with different functions, right? So what I would like to do now is leave you with this example right here. I would like for you to work this out on your own. So pause the video and follow the steps that we just did. Compute the derivative, right? So here are the steps. Compute h prime of x, okay? Then evaluate h prime at x is equal to 3, okay? And that's going to be what? That's going to be the slope of the tangent line. Okay, so determine the point. What is that point? So let's give it a name. So let's say this is point B with x coordinate being 3. Y coordinate is just h evaluated at 3, right? Whatever that might be. Okay, and then use this formula y minus y null equals to m of tangent times x minus x null to determine your equation. Okay, I am going to give you the answer to this so you know if you've done this correctly. So once you do all of this, okay, the answer should be the following. Y is equal to negative 3 over 2 x plus 15 over 2. Okay, that's going to be the equation of the line that's tangent to this graph at x is equal to 3. Okay, we'll go ahead and stop right here. Thank you for watching, and I will talk to you next time.